In this video, we're going to look at some variations on the for loop. Some of what's in this video, we're going to look at how the loop's the loop variable's initial value does not have to be anything in particular, and we're going to see a rule of thumb associated with that. We also don't have to go up by 1. The update can be values other than 1, and then finally, it doesn't even have to be positive. Okay, the loop update can be negative, and we can, combine that with a high loop variable initialization and a condition that checks for whether it's greater than the end value. See how to count backwards. All right, so start with an example here, just a basic loop, and have a variable here to control the number of repetitions. So I set that variable and display it, and then we execute a loop from 1 while we're less than or equal to whatever that number is, number of repetitions. It'll start out as 3. We print the value of n and then update. All right, so let's run that. Compile first, then execute. And number of repetitions should be 3. Okay, and it is. And if we change that to, say, 4, recompile, re-execute, yes, it's 4. All right, so this variable now we see is controlling the number of repetitions. You often want to start these loop variables at 0, but now look what happens in the compile. Okay, well, it still stopped at 4, but that's not 4 repetitions. It's 1, 2, 3, 4, 5. The 0 is another, right? That's another repetition through the loop. So the loop actually performed its task 5 times. We got a mismatch here. So if I'm going to start at 0, right, I want to make a corresponding adjustment in the relation and say, okay, well, the loop variable has to be strictly less than the number of repetitions. Recompile. Okay, number of repetitions should be 4. Starting at 0, 0, 1, 2, that is 4 repetitions. And if I say change it back to 3, all right, now I have 3 repetitions. So next, you don't have to go up by 1. This update expression increases n by 1, as you can see, from the output here. Right. But you can also count by 2's, or really any number, with an expression like this. If I want to go up by 2, I can say n plus equals 2. And the plus equals, and it goes in that order, plus equals, the plus first, then the equal sign, abbreviated expression for saying raise whatever n is, raise it by 2. Right? You can put any number you want there. All right. That says raise whatever value is in n, raise it by 3. We'll start with showing by 2. So I'm going to say raise whatever is in n by 2 instead of by 1. A new update expression there. I'm going to raise the number of repetitions. This is going to have an impact on the number of repetitions too. Right? You'll see. Right, so number of repetitions should be 6, because that's a 6. But n is going up by 2. But this is really not a good name for this anymore. Right, so I'm going to rename this variable and call it bound. Right, and it's a little misleading now to say that that's the number of repetitions, because it's not going to come out like that if the update, right, is not by 1. Right, it's only going to work like that if the update is 1. All right, so let's see if I set this a little higher now. Oops. Got to update everything in the output statement here. All right, so update by 2. All right, this can also be any number. Doesn't have to be 2. All right, here we see a 3, 0, 3, 6, 9. All right, so we can sort of count by any number. We can even make this into a variable. It doesn't have to be a literal value at all. A lot of times it's better for it not to. I'm going to make another variable up here. I'm going to call it step and use that there. So now I can control the loop. All right, with these two variables here, I can say, let's say, count to 100 by 10. Recompile, re-execute, and now I'm counting by tens. So a minute ago we saw that if we change the initial value of the loop variable, we have to keep that in sync with what relation we use, whether we use less than or equal. Or, sorry, less than or equal. All right. Likewise, okay, we have to make corresponding changes in the rest of the loop header when we change the direction of the update. Right, meaning to say you don't even have to make it, it doesn't have to be a positive number at all. Right, so I'm going to start a new loop for this. So this is a counts upward. Right. You can also make a loop that counts down. For example, int k is 10. K greater than 0. Right, so if I'm going to count down, the relation is turned around. Because I have to say, because I'm starting high, and I have to know if I'm still greater than some endpoint. And I use the counterpart to k plus, k minus minus. And we'll say k is k. Oops. Or at least a little message. Okay, loop that counts down. All right, so you see here, k starts at 10. All right, so the initial value is 10. And if this condition is true, we execute the body. Well, 10 certainly is greater than 0, so we execute this body and print k. And then we cycle back around to the update. This update expression, right, this is the opposite of plus plus. Minus minus reduces the value of a variable by 1. And then we go back and check the condition again. If the variable is still greater than 0, the body executes again at the new value, and then that's what we see here, k is 9, and so forth. Those three things have to be coordinated. Right? Obviously, to make a loop that counts down, right, you have to start at a high value, right, compare for greater than the end, and then reduce your loop variable.